This is Musab from kerneltraining.com, and I would like to welcome you for this webinar on IBM AIX for power systems and AIX. So speaking about me, I am working in kernel sphere technology for past 3.5 years, and prior to it I used to work for some other companies, and I have overall 5 to 7 years of experience on Unix platforms, especially on IBM AIX and Linux, and also I have been involved in training overall for more than 5 years, and I used to take the online classes, offline classes, or corporate batches. I've taken almost around 200 classes in this past years, and that's what a small intro about what I'm trying to do and what I'm trying these days. So let's try to see what we are here for. Before we can start that, I would like to know that am I audible to everyone? All of you, are you able to hear me properly? Can you just send me a chat message that yes or no, so that I can check it out whether everything is proper or not. And we have our presenter Chandra also. Chandra, am I audible? Chandra, am I audible? Okay, Pawan says yes. Fine. Guys, just let me know whether we are, am I audible or not, because if there is a sound issue, then there might be some problem. I would like to correct it before we can actually go for the class. So I think I am quite audible. Guys, could you please respond to me? Just chat and tell me whether am I audible or not, so that I can be sure that I am able to be heard by you, so that there might not be any problem in our overall session. Am I able to, am I audible to you? So I think I'm audible to everybody. Let's start with this session, that what we are here to. So let's try to talk about your IBM AIX and power systems, what we are trying to understand and what we are trying to learn. If anybody is not able to hear my voice, kindly message me or chat with me so that I can know whether you are able to hear or not. If you're not, then we will try to make it more clear, and then we will try to work on that. Anyway, as of now, I take it as a yes. So let's start our session. Let's try to talk about the introduction about your IBM AIX, that how this IBM AIX works and what actually IBM AIX is. Now, before I can hit the PPTs, I would just like to take you to some of the basics of Unix, that how Unix came into the picture and what actually Unix does, and then I will try to take you into the IBM AIX kind of environment, which will make us to understand very clearly. So in this scenario, let me try to start like this. What I'll do out over here is I'll try to show you some information on a notepad, where I could give you a small introduction, that how Unix got started and what are the information about that Unix is and what it is trying to do. Now, if I generally ask you that what is actually this Unix, then I may get an answer that Unix is an operating system. That's fantastic. We know that an operating system is an interface between user and the hardware, because hardware works on binary language. User cannot understand the binary language. So as a user, I need to communicate with my hardware, so I require an interface. That interface would be my operating system. That's the thing which we are learning and which we know from ages. Now let's try to talk about something different, and let's try to drag out that why Unix came into the market and how AIX is related to your Unix. So if we talk about an operating system is a bit of combination. It starts the story from here, that we'll be having something called source code, and once the source code is combined with some application, it is going to give me the most important part out of it, called kernel. And when I combine kernel with some software, it is going to give me my final output, that I would be calling it as operating system. So basically, if I talk about an operating system, I can say that operating system is a combination of kernel as well as software. And whereas, what is this kernel? Kernel is combination of source code and application. But the thing is, what is source code? Source code is something which is the instructions which is written in one or the other programming language. The most widely used programming language is C language. So source code is the instructions that is actually written in one or the other programming language. And when I say programming language, that programming language will require some libraries, some applications which would be controlling that language to have a better output. So when I combine those libraries and compilers in the form of application with my source code, it is going to give me something called kernel. Kernel, guys, is the most important part of any operating system. Consider kernel as a heart of operating system. Assume that if a human is there and the heart does not function, then you cannot consider it as a human, isn't it or not? So what happens over here is, in the same way, if the kernel of the operating system is not functioning, then you cannot consider an operating system to be there. It may be crashed down, it may be rebooted, or whatever it might be. So basically, kernel is a lifeblood of an operating system. Now, when I combine kernel with some software, very much needed software, whatever you wanted to add. For example, listening music, I'll consider VLC media player. Browsing internet, I'll take Mozilla Firefox. And for other usages like Office, I'll take OpenOffice or Microsoft Office or whatever. The needed small software which can make my interface look very nice. So when I combine these things with kernel, then I'm going to get my operating system. So this is the story that how an operating system is compiled. But why I'm trying to tell you this story, let's try to talk about it. The first ever Unix, the first ever operating system, of the world is Unix. And Unix was released in the year 1969 in at&t Bell Lab. So American Telephone and Telegraph Bell Labs. So what happens over here is, in 1960s actually, 65, 66, 67, at&t people wanted to build an interface where they can have some interactive games. Prior to it, the games was not that much interactive. They wanted to build an interface where, a Pac-Man or, something interactive games can be played out over there. So prior to it, there used to be only a Bacchus or something. So what they did is they given this project to build a platform where such games can be designed, such games can be played, to one of a very important scientist of those times called Ken Thompson. Ken Thompson was and is father of Pascal language, or you can call it as a B language. So what Ken Thompson has done is he has written the source code of this Unix in Pascal language or B language, and he totally failed out to produce the output. Now in this scenario, what happened is he combined his project with another great scientist of that time called Dennis Ritchie. I think we all are familiar with Dennis Ritchie. Dennis Ritchie is father of C language. Okay, the one who has brought C language to the world. So what happens over here is Ken and Dennis both work together to build up such kind of environment, and they rewritten the source code partially in C language, and the one which has been written in C language has got their what I can say, they got actually what results they are looking for. So in that scenario, what happens, now they got a motive that yes, this source code which is written in C language can be productive. So what they did is they have rewritten the source code completely in C language, and they came up with first ever full-fledged operating system of the world called Unix in the year 1969. Now what happens over here is, once the Unix was released, it was not commercialized. It was just a free product given to schools, universities, so that we can understand that how this operating system would work. And because of its feasibility, because of its versatility and flexibility, many industry giants wanted to purchase this Unix and they wanted to adopt. But what this at&t people have done is they have never ever sold Unix to anybody. It is totally, wholly and solely a product of at&t still. What they did is they have kept the source code on sale. They says that if you are a good programmer, take my source code, modify it, and come up with a flavor of Unix. Consider Unix as an ice cream does. Like ice cream has number of flavors: vanilla, mango, strawberry, butterscotch, whatever it might be, whatever you like. So in the same way, Unix is also having number of flavors available in the market. Let me talk about most of the few flavors, and then we will find out that how AIX is also related to it. So in the year 1982, there were two Unixes released simultaneously. One was from HP Corporation. Their flavor is called as HP UX or HP Unix. Okay. In the same year, we've got one more flavor available in the market called from Apple actually, which is called as Mac OS. Then in the year 1986, we've got one of the brilliant flavor in Unix from IBM, which they have named as AIX. And finally, in the year 1991, we've got one more very great flavor from Sun, which is called as Solaris, which is now sold to Oracle. So nowadays it is not called as Sun Solaris, it is called as Oracle Solaris. So this is how few of the important Unixes came into the market. And out of all, now if you see the Gartner's report, IBM AIX is only the Unix from past 30 years or more than 30 years, which is actually seeing the growth in the market. HP UX is also available in the market, but not that much. Sun, we already know what happened to it. Slowly, there was a downfall in Sun, and after Oracle took it, there are chances we might see that Sun, Oracle, or Solaris back into the picture, but it may take some time. Whereas if we talk about Apple, Apple is something a very, very domestic product nowadays. You can see desktops, you can see iPhones, you can see iPads, you can see iPods. So basically, it's just like a domestic product, not into the production environment. So what is left now is IBM AI. One more thing, guys. If you see all these Unixes, why they are so much solid and why people, talk about these kind of Unixes whenever it comes to Unixes, the reason is all these flavors, whatever you see on the screen right now, are hardware dependent kind of operating system, or you can call it software proprietary kind of thing. So in this scenario, what happens is, if I wanted to go with HP UX, then I require HP's hardware. If I wanted to go with Mac OS, then definitely I require Apple's hardware. In the same way, if I wanted to go for AIX, then I require IBM's hardware. Same is the case with Oracle Solaris. We require specialized hardware in order to run it. So this software and hardware combination make it rock solid. What happens over here is, most of the time people will be having a very good software, but to support it, you don't have the better hardware with you. In that scenario, the performance of that particular software is degraded only because of the hardware. Let me tell you a small example, guys. Let's say we have a good rider, a good biker, the one who can ride at any speed in the world. He can go to 200 kilometers, he can go 300 kilometers. Assume that to that particular rider or a biker, if I give him a moped like Luna, can he make a difference? No. So in that scenario, what happens? Many of the operating system, because of not having that kind of setup, not having that kind of hardware to support that software, does not able to perform well. But AIX or other Solaris tries to cover up that gap by making that particular software run on a specially designed hardware which can give you the best performance. And that's the reason IBM and AIX combination is quite deadly in the market. Okay, so this is how we have tried to understand that how IBM AIX came into the market. Let's try to talk about more on the hardware level, that IBM, what are the hardwares they sell and which is the hardware that is related to AIX. So let me take you back towards the slides. So if we talk about the hardware in your IBM, let's try to talk about what is the hardware that is being used from IBM. IBM has most probably three types of hardware. One is you are having IBM X series kind of hardware. So IBM X series is probably used for Intel based processor based on CISC technology, complete instruction set computing. It's a kind of CPU technology, which is now a Lenovo X series. So probably, it was earlier an IBM X series. So what IBM does now, as they have sold the X series to Lenovo, Earlier it was used to called as IBM X series. Now it is called as Lenovo X series. And probably these X series are designed to run Windows, Linux, VMware, Citrix, all these kinds of flavors can be easily attached on that, and it is available in 32-bit as well as 64-bit architecture. Whereas if you talk about one more series, IBM P series, as we are trying to learn AIX, IBM P series is the very important series for us to remember. IBM P series is wholly and solely used for AIX. Okay, and this particular IBM P series is RISC-based technology. RISC stands for Reduced Instruction Set Computing. The major difference between CISC and RISC is CISC does not have any compression of data to process more data at a time, whereas RISC perform a compression of data to process more data in one CPU cycle, which actually increase the performance of your processing. Okay, so basically we have to remember that IBM P series is a series which is totally dedicated for AIX environment. Now as soon as I say that I want to work with AIX, then AIX is always related with P series, and P series is still a proprietary of IBM. X series have been sold, but P series still belongs to IBM, and which is totally used for AIX environment to put AIX, AIX cluster and AIX virtualization. One more thing, it is only available in 64-bit architecture. We have one more series, IBM Z series, or you can call it as Z series, which is used for mainframes. So these are the three major series which is available from IBM. Now one of the series have been sold to Lenovo as discussed. Let's come back to what is power over there. Okay, this P series, what we are trying to look, see in the slide also we are trying to talk that IBM power system. So what is this power? Power, does it mean strength? Does it means a strengthened kind of thing? No. Here the power has its own abbreviation, and the abbreviation is P for performance, O optimized, W with, E enhanced, R RISC. So overall it is performance optimized with enhanced RISC. So what they did is in the power series they brought up RISC based processor with high compression quality so that it can process more data, more things in one CPU cycle which cannot be done on other processes. Okay, so basically that P or power stands for performance optimized with enhanced RISC. Okay, then let's try to talk about your AIX. AIX stands for Advanced Interactive Executive. So this Advanced Interactive Executive is something you might see that why they have kept this kind of name, Advanced Executive. So let me tell you that why they have kept this name. AIX stands for Advanced Interactive Executive, whereas Interactive is a company that has developed this particular software for IBM. So IBM got this particular thing developed by Interactive kind of a company. This is the company who has done this kind of development for AIX, and obviously when interactive people have developed this kind of operating system for IBM, so just they have kept the name on the top of the developers, which is Interactive Inclusive. So AIX stands for Advanced Interactive Executive, which is one of the flavor of your Unix operating system. So AIX IBM version of Unix compete with Microsoft Server operating system or other proprietary Unix systems such as Oracle Solaris, HP, True Unix, All Linux, whatever it might be. AIX is mainly used for enterprise business computing. The latest version of AIX is AIX 6.1. 7.1 is the one actually which is latest. So that has been released in 2009. So 7.1 is the latest version which is available, but probably there are no huge differences between 6.1 and 7.1. So almost whatever I can do on 6.1, it is exactly similar to 7.1. Just 2 or 3 things might be here and there. AIX comes with something called LVM, Logical Volume Manager, integrated with operating system by default. AIX support LPARs. Now this is something which is very important and interesting. Guys, you might be surprised to know, or maybe you might be knowing, if I'm not wrong, that virtualization is a kind of technology that have been introduced by IBM people for the first time in the world, and that too in IBM machines. So probably what they have done over here is, they have introduced the virtualization over here. Probably what happens in virtualization, I will try to take one machine, and that physical machine I will split into many machines. This particular concept is called as virtualization, splitting the physical resources into logical resources. Assume that in earlier days, if I have 3 or 4 applications to run, major application which cannot be fitted in one box. So in that scenario, I may be taking multiple physical machines for each application. For example, let me say I have a database running, I have a middleware running, I have an SAP application running. So altogether, I need 4 physical machines running all the time. So if I talk about 4 physical machines, then I require the place to keep that 4 physical machine. 4 physical machine will consume power for me, and to maintain that 4 physical machine, I require an administrative cost. So all it requires a huge investment over there in order to work with multiple individual machines. So what they did is they have introduced a feature where I can have one box with many machines. Each machine will be behaving as an independent machine over there. So what I can do is, on one machine I can put my application, on one machine I can put my middleware, on one machine I can put my database, on one machine I can put my other applications which are necessary like SAP or whatever it might be. Each machine will be functioning as a better machine over there. So in this scenario, I don't require multiple machines to be there. All virtual machines will be consuming the power from same machine. So I'm going to save the place where I'm trying to put it. Secondly, I'm going to save administrative cost. I'm going to save the power bills kind of cost. So this kind of technology is actually introduced by IBM in your power machines for the first time. So IBM has its own terminology to call the things with some name. What happens over here is, generally the thing which we call it as VM, in IBM terminology we call it as LPAR. LPAR stands for logical partitions. Generally we call it as VM, and in IBM terminology we call it as LPAR. So this is a kind of feature that is also available in your AIX kind of thing. So AIX support LPARs, logical partition. It supports both hardware form LPARs and software form WPARs. WPARs are nothing but I can divide my operating system into 2 parts or 3 parts. That is called WPAR. I think in Solaris we call the same concept as zones. AIX support the newest hardware that can support 10 gigabits of Ethernet. AIX is compliant with System V Unix systems. AIX provides advanced system security features. AIX has advanced diagnostic application for hardware as well as software. Now let us try to talk about some interesting things in your AIX. Now AIX was released in 1986, and the version they used to have is 1.0, 2.0. Then in 89 they have version 1.1, which used to run on PS, or I can say PS is nothing but your power systems on 2 PCs, or I can say 2 CPUs actually. 89 AIX version 3.0 released, which was running on RS 6000 or RISC 6000, 92 3.2, 94 4.0, 95 4.1, 96 4.2. Like that, you can see the major versions that actually came into the market was from 2002 on Power 5.1 on Power Series, 5.2, 5.3, 6.1, and very latest 7.1. Now let's try to talk about the hardware and software combination that have been released. So as discussed, in 1986 you have seen that we are having IBM AIX 1.0 got released, and it was released with RISC technology. Similarly, till 1989, we've got 3.0, 1990s, Power series was introduced. Prior to Power, it used to be called as only pure P systems. Then it was started as calling as Power System because they introduced a new technology, performance optimized with enhanced RISC. They modified the RISC technology to take more and more processing in one CPU cycle. Similarly, AIX 3.25 was released in 1993, Power 2. 1994, AIX 4.1 was released. 1996, 4.2 was released. 1998, Power 3 was released. But the major change in the market for IBM AIX was from Power 4. What was that in Power 4? Why it was called as a very popular series? Power 4 series is actually the series from where IBM has introduced virtualization. As just now what I have tried to explain you, the same thing, virtualization was introduced from Power 4 machines. And when Power 4 was released, AIX version 5 was also released. In the same way, it continued to run till 2002 as 5.2. Then a very brilliant combination of Power 5 and AIX 5.3 was released in 2004. This, my dears, was a very big change in IBM to acquire the market. Power 5 was a model and AIX 5.3. These two combination was actually a kind of combination which has given a new identity to IBM Power Systems and AIX in the market. So IBM got their name and their fame from Power 5 and 5.3 of AIX version. Then we've got Power 6 was released in 2007. AIX 6.1 was also released. Then we've got 7 version released in the market. Okay, AIX 7.1 2011, and in 2000 what I can say 7 itself, at the end, or 2008 beginning, we've got Power 7 machines also available in the market. We're going to talk about Power series more in the coming slides, because to understand the software properly, you should have a proper knowledge of the hardware. Any AIX admin should know this particular differences very well, because the change in hardware is for supporting the new software. So if I don't know that what software support what hardware, then I may not be able to properly work with that, or I may not be able to cope up with that. So let's try to talk about few of small requirements like Power 4 LPAR requirements. That's, as I've told you, that from Power 4 virtualization was introduced, and these changes are very important for us to remember that what is the feature of Power 4, what is the feature of Power 5, and what is the feature of Power 6 and 7, so that we can actually understand how AIX works and what are the differences that came in all these series. So when we talk about Power 4, in Power 4, as I have told you, that the requirement is quite very simple, that I can go for virtualization. Virtualization was actually first introduced in Power 4. So when I go for Power 4, in order to create an LPAR, the requirement was very simple. There is only two things which is required for creating an LPAR in IBM environment. To create a VM, generally what we call, but in AIX language we call it as LPAR. Create an LPAR, the minimum requirement is only two things. One is memory and one is CPU. If you have these two things, you can create an LPAR. Later you can give the disk and you can install the operating system. But to make a VM, we require only two things, memory and CPU. To create a minimum memory, to create an LPAR, the minimum memory required is 128 MB, and this particular thing has never changed. Till date, even you have Power 6, Power 7, Power 7 Plus, for everything we have 128 MB of requirement. This requirement of memory has never been changed till date. Now, when it comes to CPU, in CPU, to create an LPAR in Power 4, we require 1 unit of CPU. That is nothing but 1 CPU in full, or 1 processor. So if I have 1 processor, then I can make only 1 partition. Like we all know that on your server level, we can have multiple processors. So your server comes with 2 processor, 3 processor, 4 processors. So in this scenario, if I have 4 processors, assuming, then I can go for 4 LPAR, giving one CPU to each, and minimum memory I can give is 128 each. 128, 128, 128, and 128. The same memory I can give it to all and I can work. But the problem arises over here is, assume that I have one processor given, I have 1 GB of RAM, out of which 512 divided into 128, 128, 128 I have given to all LPARs. Assume that one of the LPAR requires more CPU or requires more RAM. Assume that I don't have a CPU with me, but that I have RAM left with me. Out of 1 GB, 512 is used. 512 is still with me. Now if I want to increase that particular RAM, or if I wanted to make any changes in that particular LPAR, maybe I want to create a virtual Ethernet, maybe I would like to create a virtual fiber channel adapter, maybe I want to do any task on that particular LPAR. So in order to make any changes on that particular LPAR, you require a dump. You cannot make that changes online. To increase the RAM, to decrease the RAM, to increase the CPU, to decrease the CPU, to do any kind of activity, I require a downtime. I require a definite downtime to do this activity. That was the problem when it comes to that is required when we try to work with your Power 4 LPARs. Now this was actually something that concerned the people before purchasing the IBM Power machines. Exciting thing was there is virtualization. But to maintain it, we require certain downtimes in every step. That was something which was a disheartening kind of thing. So what people did is they went for it, but they have to bear this pain that every time whenever they wanted to do any task, they require a downtime. So what they did actually after this is they have introduced a new kind of server, that is Power 5 server. What was new in Power 5? As I've told you guys earlier while I was discussing the slide, that Power 5 and AIX 5.3 is a very important combination in the history of IBM Power series to give them the name and to bring on a big Unix name and a big share in the market. What was there in Power 5? Most of the feature, whatever we see even till date, are carry forwarded from Power 5. So they have introduced Power 5 with many features in them. Now what was those features? Let's try to talk about it. So the features goes like this, that the memory requirement, as I've told you, has never been changed. It is still 128 MB per LPAR. So if I want to create an LPAR, I require minimum 128 MB. But while we are talking about CPU, there has been a drastic change over here. Earlier, they was asking us to give at least one physical processor to this particular LPAR in order to go for virtualization or creating an LPAR. But with the help of Power 5, they came up with the new idea that now if you want to create an LPAR, you don't require one unit of your CPU. Rather, you can simply give 0.1 unit, which is nothing but 1/10 of your entire unit. That means now if I have one processor, that means I can convert that one processor into 10 and I can make 10 LPARs. That was the big change over here. So I don't require anymore to give one full CPU to the entire LPAR and work with that. Instead, I can go for this virtualization feature and I can have only 0.1 unit per LPAR. So that has what I can say increased, and that has made the scalability available in your IBM Power machines. At the same time, just before, we have talked that if I wanted to create an LPAR, it can be simply created. To make any changes in Power 4, we require a downtime. There is a downtime here. But when it comes to Power 5, there was no downtime over here. To increase or to decrease the resources on your LPAR, I can do it up and runningly without the need of your downtime. Let's say I want to increase CPU. If you have, increase it up and running. If you want to increase the RAM up and running, increase. There is no downtime involved inside it. Everything can be done dynamically. And this particular concept is called as DLPAR. So now my LPARs are called as DLPAR. I can do a dynamic changes on my LPAR which does not require downtime. This was a very fantastic feature which has actually helped a lot of people to put your machine on a production continuous without a required of unnecessary downtime to make any changes in the LPAR ladder. Then we came up with one more feature over here called micro partition. What is this micro partitioning? Let's try to talk about it. Guys, to create an LPAR, I require minimum 0.1 unit of CPU. Very good. So let's say I have created an LPAR with 0.1 unit, 0.1 unit and 0.1 unit. Assume that I want to increase the CPU of any LPAR. Ideally, if I think how much CPU is needed to increase, I would say another 0.1. Yes, generally what we think. But what IBM has introduced is once your LPAR is created, later on if you want to increase the CPU, you don't have to give another 0.1 unit. Instead of that, I can increase the CPU in 0.01 unit, which is what? Actually, it is 100 of 1.0 unit. That means the smallest part of your CPU will also not be wasted. So let's say if I have to increase, I don't have to give another 0.1. I'll simply give 0.01 or I'll give 0.02 and I'll give 0.03, whatever it might be. But I can give the smallest part over here to make it function very better. Even the smallest part will actually boost up the energy and boost up the performance for your LPARs. So as and when it is required, I can make the smallest thing shareable and make the performance very well over here. Now let's talk about one more feature over here that is called AMS, Active Memory Sharing. Now guys, what happens over here is, as of now I'm trying to feed memory over here. What is the minimum memory I can give? I can give minimum 128 MB memory. So I'll give 128, I'll give another 128, I'll give another 128, and if required any point of time, I'll increase the memory. But all the time I need to monitor my LPARs for their memory consumption. Assume that most of the LPAR does not really require high memory every time. So let's say what happens, one of the LPAR is very important to me. So what I'll do, I'll give high memory to that LPAR. Assume that I'm giving 1 GB of memory, 2 GB, 4 GB, whatever it might be. Other LPARs I'm giving 128, 128. Now, do you think all the time this 1 GB will be consumed by that LPAR? Not many times. Especially when the weekends are there, the memory consumption will be very low. And when there is, what I can say, a working peak hour, especially on Mondays or Tuesdays, it would be very high. So in that scenario, I need to manage the memory manually, give some LPAR more memory and take the memory from other LPAR, or they reduce the memory for one LPAR which is not important and feed it to the other LPAR which is very important. So here the management of the memory has to be done manually. So what they did is they have introduced another feature over here called active memory sharing, where I don't have to directly feed memory to my LPAR. Rather, I'll simply create a pool of my memory where I'll keep my memory, which I would be asking my LPARs to automatically take the memory according to their appetite. Let's say one LPAR require more memory, they'll take more. When LPAR require a small, they won't take anything. One LPAR does not have any need of memory whatever they have consumed. So what they do is they'll withdraw the memory and give it back to the pool. So like that, the memory management becomes very simple. So here automatically the memory is given to an LPAR, and once the work is done, the LPAR will give back the memory to the pools. So like that, I can make multiple pools of my memory. One pool for all DB application LPARs, one pool for all SAP application LPAR, one pool for all another application, whatever name it might be. So like that, what I can do is, for all LPARs, I can actually segregate my memory and I can make sure that database LPARs are always getting this much of memory. Other LPARs are getting this much of memory. So like this, I can make my pools and I can work with my memory. This concept is called as active memory sharing. All these features was introduced from your Power 5. So you can see how intense they have developed Power 5, and they came up in the market to take the higher share in the market, and they succeeded in the plan because it was having most high features that was ever introduced before it. Then we've had Power 6 came into the market. Power 6 is exactly same like Power 5. All the features whatever we have discussed up till now is again carry forwarded in Power 5, except there was one small change over here, and that small change was live partition mobility, or in short I can call it as LPM. Now what is this LPM? Let's try to have a small introduction about it. LPM is live partition mobility. That means moving an LPAR live from one physical machine to other physical machine in case of an event. Assume that I have two Power 6 machines in my environment. Each machine is having some LPARs. Now let's say for some maintenance work I am bringing down this physical machine. Now if I bring down this physical machine, then what about the LPARs inside it? They would also be down. But one of the LPAR is very important, which cannot be down. It is my production LPAR. So in this scenario, what I can do is, if I have the identical box, at least P6 to P6 or higher, maybe P6 to P7, I can migrate this LPAR live while it is in use, while people are using it, while applications are running on the top of it. So my LPAR will move to the other physical box which is compatible to live partition mobility, and it will continue run on the other side of the box. And I can bring down this LPAR, I can bring down this physical machine, I can make the change whatever I wanted to do. Maybe I'm upgrading the RAM or changing the CPU, or there is some defect in motherboard. Whatever repair work you have to do, you can do it. And once it is done, you'll power on the machine, and again you will bring that back to the original place. So like that, I can move a partition when it is actually in use from one physical box to other physical box, and it drastically put your LPAR away from downtime. So this is the feature that has been introduced in Power 6. In the same place, what happens is, due to lots of features that was carry forwarded, live partition mobility was there, but they have increased the CPU clock speed over here, which was actually consuming a very high power over there. So what problem was Power 6 facing is the high power consumption. So what they did is, rather than correcting the Power 6 and bringing again into the market will give a negative name to IBM. So what they did is, within 1 year itself, within an year, they have reintroduced Power 7. They have introduced Power 7, not reintroduced. So what Power 7 is it is exactly same how P6 works. All the features of P6 is available over here. You can work with VLPAR, you can work with micro partitioning, you can work with all the other features that is available in the system, except it consumes 50% lesser power than Power 6. Okay. But what happens over here is, as it was released very near to the same year when was Power 6 released, so many people has jumped from Power 5 to Power 7 rather than going to Power 6. Obviously, whenever there is a new product available in the market, people will not go for it immediately. It takes some time for the people, for the companies to adopt the new hardware, probably which will take 1 year or more than an year. So since Power 6 was released, and within a year Power 7 was there in the market with better features, less power consumption, so people moved from Power 5 to Power 7. So in this scenario, you may not see Power 6 widely available in the market as Power 7. Now let's see what are Power 6 models or Power 7 models look alike. So this is Power 6 model, Power 7 entry level model 520, if you can see. This is a very basic level model or entry level model which is available, and this comes in two shapes. One is tower model and the other one is a rack model. Tower model is just like your CPU what you have, and the rack model fits properly into the rack and behave, look very nice. Then we have Power 550 available, a bit more big than 520, and we have 550 in again tower model as well as rack model. Then we've got Power 6 560 model, which is also called as building block model. Now over here what happens is, we have two blocks model. Assume that I want high CPUs. Maybe I'm looking for 16 CPUs or 32 CPU. So all that hardware cannot be fixed in one block. So what they did, they have released it in multi-blocks. So this model is also called as block model. Now a kind of funny thing, if you can see, I would tell you, is all the other models, whatever we have seen up till now, like Power 4, Power 5, Power 6, assume that I have multiple models in each series. Power 4 has multiple models, 410, 430, 450, whatever it might be. Power 5 have few models, 510, 520, 550, 560, 580, like that. There are many models. The last model, 595 in Power 5, is very, very powerful model. But if you see Power 6 also has this 5 letter inside it. It does not say 620, 650, 660, 670. No, it's again carrying the same tag of 5. You know the reason? The reason is quite simple. They wanted to carry the same legacy of Power 5 machines, because Power 5 machines was very popular. So they just don't wanted to lose away that charm. So what they did, the Power 6 machine also, they have given the same series, 510, 520, 530. Rather, we called Power 5 520, Power 6 520, Power 5 550, Power 6 550. So like that, what happens over here is each series is having initial. Power 5 is starting with Power 5, Power 4 starting with 4, but 6 again start with 5, because they wanted to carry out the legacy which was there earlier. Okay, so 560 looks like this. 570, again many blocks inside it, at least 4 blocks. Then you have the most powerful series in Power 6, Power 6 595, Power 5 595, Power 6 595. These are very, very popular. In any series, guys, whatever the last available model is a very, very popular model. Then let's talk about what are the features of Power 6 different models, whatever we have talked. As I've told you, Power 5 520 is entry or low-end model for a small business, I can say. It is available in desk side as well as rack. The CPUs I can have inside is 1, 2 or maximum 4. The memory it can have is maximum up to 64 GB. The maximum storage supported by 520 is 132 terabyte, not more than that. Then we have Power 5 550, which is also called as mid-range servers, which is also available in desk side as well as rack. Just now we have seen over there above that 550 is also available in desk as well as rack model. So when we talk about this 550 and model, it is available in desk side as well as rack. CPU it can have is up to 8 CPU, 2, 4, 6 or 8, multiple of 2. Memory it can have maximum is up to 1 GB to 256 GB, and the storage it can have is 249 terabyte. Then you have Power 560, which is also a mid-range model, but which is a building block model, which comes in 2 blocks, okay, which can have maximum up to 384 GB. Maximum storage it can have is around 600 terabytes. We have Power 570, which is again a mid-range, which comes in rack building block model, which will be having multiple blocks inside it, which can have 2, 4, 8, 16 or maximum 32 CPU. The memory it can support is up to 768 GB, and the storage it supports is 6, not 4 terabytes. Then we have Power 575 model. Speaking about this model, guys, this model is not a good model in the history of IBM Power series. It was released, but none of the customer has purchased it. So it is also a failure kind of model which does not work very high. Probably it was released for high performance computing or clustering kind of environment, and it was introduced with some new things inside it, that was water cooling technology, something like that, which does not actually work properly. Do you see water cooled technology. So that means you have to maintain some water inside it and something like that. People does not like it and they didn't went for it. Rather, they have opted for the most powerful machine, 595 machine, high-end 42 unit, up to 64 CPU, which can give you support up to 4 terabytes of memory, and the storage, internal plus expansion, can be around 999 TB. So this was the information about Power 6 servers. Let's talk about Power 7 servers. Power 7 servers was introduced with a very compact way, a thin way, where they have reduced the size of rack. The same thing if you try to see in your other model, you'll see that the rack size is big, but whereas when we see in Power 7, the rack size was reduced from 4 unit to 2 unit. The things was very compact inside it. Instead of putting the big disk, they have put the disk in a very small size like your laptops, and everything was very small. So in IBM Power series, we have 710, an Express edition, or we can call it as Introductory edition. And observe guys, from 7 they are again back with the proper series. 7 series is again called 710, 730, 750, 790, 795, so and so. Not like P6 where it was again called as P6 550, P6 570, something like that. Okay, so P7 supports up to 64 GB memory RAM. It can have up to one 3.7 gigahertz processor, and it is also supported with what I can say HMC and all. So one Power 7 3 gigahertz 4 core, one Power 7 3.55 processor 8 core. So those are some classification what they have came up. Then we have 720 Express, which is also available in desk side, also which is available in the rack side, which is a big in the size, not like the previous version. So it support up to 128 GB RAM, and which can have only one processor, but the speed of the processor can be 3 gigahertz, which supports up to 8 core. So either I can have one Power 3 gigahertz 4 cores, or I can have one 3 gigahertz 6 core kind of processor. Then you have 730 Express, which can also support up to 128 gigahertz, but here I can have up to 2 processors of Power 7. Then we have 740 series, which can have up to 2 processors in different cores, which have been listed out over here: 3.3 gigahertz, 3.7 gigahertz, 3.5 gigahertz, with all core calculation 4, 8, 6, 12, 16 cores maximum. Okay, then we have something called 750 Express. These models are an enterprise models, or I can say a mid-range kind of model where you can run your production very well. So here I can have this particular model with 512 GB of RAM. I can have up to 4 processor, each can be 3.55 gigahertz, or you can go for any lower speed with this kind of cores kind of compatibility. Then you got 770, which is again a building block model, which can have up to 512 GB of RAM, and I can have up to 2 processors inside it, and which can be each 3.5 gigahertz up to 6 cores. Then you have 780 model. Now this kind of model is a mid-range model which comes with a rack itself. So which can be up to 512 GB of RAM, supports up to 2 processor, but 4.1 gigahertz. That's a big. Then you have Power 7 795, the most powerful up till now whatever series you might have seen. It is a high-end enterprise class which can support up to 8 terabytes of memory, which can have up to 32 CPU, each can be 4 gigahertz. Okay, and you can also put turbo option to put 128 CPUs, which is a great. Okay, so this is the differences what we have seen between Power 6 and Power 7, the very latest models available in the market. Power 7 is the latest of all. Power 7 Plus has also been introduced, but that is not that quite popular as Power 7 series, which is currently an ongoing series in the market. Now, there is one more technology that have been used either in Power 6 or Power 7, which is called as Bladecenters. Like this technology was actually started by Sun, and then later on people have adopted it. Now we have HP blades, we have IBM blades, or we have Solaris Sun blades is also there. So the blade comes in this form in your AIX environment. The entire thing, what you see out over here is your blade chassis. In this blade chassis, I can have up to 14 blades running in the same chassis. The size of these blades are very compact and are very small, but the performance is equivalent to the rack model or the desktop model, desk side model what we have seen. But not to be very happy, blades are only available in what I can say entry level or one or two mid-size, but you cannot see the enterprise level machines in blade like 785 or 795. This kind of machines cannot be run in blade. It is only for introductory like 710, 730, 750 can be available in the blade. Others cannot be run. But for any organization who is looking for economic kind of thing, this is the best solution. You have 14 blades in one chassis consuming very less power, but the performance is equivalent to what you purchase with that giants to increase the power consumption in your data center. This is what, guys, I was trying to show you, that these are the things that is available in your IBM series up till now. We have AIX 7.1 as the latest version and Power 7 series as the latest hardware series. So this is what we were trying to taught you. Now, if you have any questions, you can put forward to me. And one more thing, guys, before we can go for the questions or any other queries, let me tell you something about Kernel Sphere. That in Kernel Sphere, we have a great data center. We have all the things available in our data center where we can teach you on the real-time environment. We have Power 5 machines, we have Power 6 machines, we have a latest technology in your blade system called PureFlex. Now, if you see this blades, whatever I have shown you, it can only support P series blade. That means in the same chassis, I can only keep the power blades. I cannot keep the X series blades. So if I want to maintain the X series blade, then I have to maintain two chassis. One for your power series and the other one for your X series. Now IBM came up with a new technology calling it as PureFlex, where I can keep X series blade as well as power series blade in the same chassis. So that kind of thing is also available in Kernel Sphere in our data center. Apart from that, we have Power 5, we have Power 6 machine running on AIX 6.1, on 7.1. We have multiple SANs available in the market and in our data center, like we have VMC Clarion, we have NetApp, we have VNX, the very latest, we have symmetric model. All these storages are integrated with our AIX machines, so where we can actually see that how LUNs are coming to our machine and how we are using the storage in our AIX environment also. And apart from that, we have other virtualizations used apart from IBM virtualization, which is LPAR and VIO. Apart from that, we have VMware done at our place. We have Citrix kind of environment. We have complete networking done in our environment. So overall, I'm just trying to tell you that the data center, what we maintain over here, is highly equipped with all the new features, cutting edge technology, an exact replica of what we do in our real-time scenario. So whatever we are trying to do, the practicals, everything is available in our data center. Our own things are there, integrated with the SAN, integrated with different things. So we can try to see actually how the real-time work goes on and how we actually work with this kind of. So probably, guys, this is what we have, and we are trying to provide you the best possible training in the market. So that's all from me, guys. Now if you have any questions, kindly put forward so that let me answer you those questions.